Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. A junior admin at a financial tech company just merged a branch called Feature Payment straight into production. No tests, no code review. That mistake could cost the company hundreds of thousands in lost transactions and days of downtime. This isn't a freak accident. It happens constantly when teams treat Git as an afterthought. By the end of this video, you'll walk away with 3 concrete skills. First, you'll master the Git workflow: commits, branching, and merging, so you can work safely on any project. Second, you'll collaborate on GitHub through pull requests, code reviews, and issue tracking. No more emailing zip files around. Third, you'll set up automated testing and deployment with GitHub Actions, and you'll wire in Claude code to review pull requests and even generate branches from issues. These are the foundations every IT pro needs to contribute to a modern team. Git is non-negotiable for 3 reasons. First, version control is a time machine. You can rewind to any previous state. Second, it enables seamless collaboration without stepping on each other's toes. Third, every developer has a full copy of the repository, so your code is backed up by default. Understanding Git's 3-stage model is the key to never losing work. The working directory is where you edit files. When you're ready, you stage the changes you want to keep with Git add. Think of the staging area as a green room for your next commit. Finally, Git commit takes a complete snapshot of everything in the staging area and stores it in the local repository. That snapshot represents your entire project at that moment, not just a set of file diffs. You can jump back to it anytime. Before creating your first repository, make sure Git is installed and working correctly. Use the git version command to verify your installation. Then configure your global username and email address. These values become part of every commit you create and identify you as the author throughout the project's history. Rather than memorizing the exact command syntax, follow along with the on-screen demonstration, where you'll see each command entered step by step. Once your identity is configured, review your settings to confirm everything is correct before making your first commit. Before making your first commit, what 2 pieces of information should you configure in Git? Take a moment to think about it. The answer is your username and email address. These identify you as the author of every commit and become part of your project's permanent history. Once those are configured, you're ready to start tracking your work with confidence. Now let's make sure Git's workflow is clear. After you've edited a file, where does it go before it becomes part of your repository history? Pause for a moment before answering. The answer is the staging area. Your working directory is where you make changes. The staging area lets you decide exactly which changes belong in the next snapshot. Finally, Git commit records that staged snapshot in your repository history. Understanding these 3 stages is the foundation of everything else you'll do with Git. If you're wondering whether Git is worth the effort, here's the data. Git's dominance is staggering. Nearly all professional developers use it as their primary version control system, as consistently shown in developer surveys. This isn't a niche tool. It's the universal language of software collaboration. Here's the most common Git mistake. You edit a file, type git commit, and Git replies, "Nothing to commit, working tree clean." The simple fix? Stage your changes with git add first. Once files are tracked, you can use git commit with the a flag to stage and commit in one step. But be careful. That flag grabs every modified tracked file, including ones you didn't intend to commit. Always run git status before committing to see exactly what's about to go in. Once you've made a few commits, you need to explore your history like a detective. Git log, ownline, graph, all gives you a compact tree view of your entire repository. Every branch, every commit in one readable line. To see what you've modified but haven't staged yet, run git diff. And to inspect a specific commit, use git show with a commit hash, or a relative reference like head_1. That's the second to last commit. These 3 commands are your time machine dashboard. Every developer makes mistakes, but Git gives you several ways to recover. Use git restore to discard unwanted file changes, git revert to safely undo a commit by creating a new one, and git reset only when you fully understand how rewriting history affects collaborators. Learning how to recover confidently is just as important as learning how to commit. 2 network engineers, same firewall script, same afternoon. Engineer A tweaks port 443 rules. Engineer B adds a new subnet whitelist. They save and push, and Engineer B's file overwrites A's changes completely. Without branching, every save is a landmine. Git branches give each engineer their own isolated copy of the codebase. Conceptually, a branch is just a lightweight pointer to a specific commit. To create one, run git branch feature X, then switch to it with git switch feature X. You're now free to experiment without stepping on anyone else's work. Here's the feature branch workflow. You start on main, the stable integration branch. When you want to build something new, you create a branch. Say, feature, login. That's your isolated workspace. You make commits as you go. Add the login form. Wire up authentication logic. Meanwhile, main stays untouched. Once the feature is tested and reviewed, you merge it back into main. The merge commit tracks both the feature tip and the latest main as its parents. Branches are so cheap in Git that you can spin up a dozen, experiment, discard bad ideas, and keep main pristine. Sooner or later, 2 people will edit the same lines of code. That's called a merge conflict, and Git will pause the merge until you decide which changes to keep. Don't panic. This is a normal part of collaborative development. Read each conflicting section carefully, combine the correct changes, remove the conflict markers, test your code, and then complete the merge with a new commit. Merge conflicts aren't failures. They're Git asking a human to make an informed decision. Quick review. Why should you create a new branch instead of working directly on main? Take a moment before answering. The answer is that branches let you experiment safely without affecting the stable version of your project. Multiple developers can work on different features at the same time, and only reviewed tested changes are merged back into main. Branching protects both your work and your teammates. Branching power comes with some discipline. First, name your branches clearly. Feature, add to FA, bug fix, login, redirect, so everyone knows what it's about. Second, commit frequently with messages that future you can decipher. Third, before you open a pull request, pull the latest main and resolve any conflicts locally. And fourth, once merged, delete the branch. A tidy repo is a fast repo. Let's test your understanding. You've already created a branch named bugfixtypo. Which command moves you to that branch? Pause before answering. The answer is git switch bugfixtypo. After switching, every change you make belongs only to that branch until you decide to merge it. That's what makes Git branching such a safe way to experiment and develop new features. Now let's create a real GitHub repository. Go to github.com/new, or click the plus icon in the top right and choose New Repository. Name it something meaningful, in this case, My First Repo. Decide if it's public or private. We'll go private for now. Check the box to add a README, which gives you a starting point. Then hit Create Repository. On the next page, you'll see the remote URL. Click the copy button next to it. That URL is what we'll wire our local repo to in the next step. With your GitHub URL copied, run git remote add origin and paste the URL. This links your local repo to the remote repository on GitHub. Verify with git remote-v. Now, the first push, git push. -u origin main. The -u flag sets the upstream, so future git push works without arguments. When it asks for credentials, enter your GitHub username and, here's the trick, use a personal access token instead of your account password. To create one, go to GitHub Settings, Developer Settings, Personal Access Tokens. Generate a classic token with repo scope and paste it. Token authentication is now the standard secure method for Git operations. You can also use SSH keys for even more convenience. Let's contrast the old way with a Git and GitHub workflow. Before Git, sharing code meant emailing zip files with names like project version, yarn final2 real.zip. If your hard drive died, the code was gone. No history. Teams took turns editing files to avoid conflicts, and merging meant painstaking manual comparison. No one could tell who changed what or why. With Git, every change is tracked, distributed, and restorable. GitHub adds a collaboration layer. Branches let everyone work simultaneously. Pull requests provide structured code review, and actions automate testing and deployment. The productivity leap is massive. A financial services company lost $2 million because a developer merged a pull request that disabled authentication checks, and nobody reviewed it. The change went live, unauthorized transactions poured in, and the fallout was catastrophic. This is the pull request trap. Assuming that because code compiles, it's safe to merge. In real collaboration, a pull request is your team's safety net. It invites scrutiny, catches logic flaws, and ensures that every change has a second pair of eyes. But that only works if you take reviews seriously, not just a rubber stamp approval. Before you even open a pull request, let Claude do a pre-review. Run this command, git diff main feature, then pipe it into Claude with a prompt asking it to check for logic flaws and missing tests. Claude will read the entire diff and flag potential problems before a human even sees it. After you act on its feedback, only then head over to GitHub and click that Compare and Pull Request button. Before opening a pull request, what's the best way to compare your feature branch against main? Take a moment before answering. The answer is git diff main, feature branch. Reviewing the difference before asking someone else to review it helps you catch mistakes early, reduce unnecessary feedback, and submit cleaner pull requests. Whether you're reviewing the changes yourself or asking Claude Code for suggestions, always understand your own diff before merging. A pull request is your final quality checkpoint before code reaches production. Think of it as airport security, not a formality, but a safeguard. Keep pull requests focused and reasonably small so reviewers can understand every change. Explain what changed, why it changed, and how someone should test it. Link the related issue whenever possible. And remember these 3 rules. Never merge your own pull request without review. Never push directly to the main branch. Never merge while automated tests are failing. The authentication bypass we discussed earlier happened because the review process was skipped, not because Git failed. Good pull request habits protect your code base just as much as good code does. One final pull request question. What's the most important rule before merging code into your main branch? Pause before answering. The answer is never merge code that hasn't been reviewed and hasn't passed automated tests. A pull request isn't just about sharing code. It's a quality gate that helps protect your production environment from preventable mistakes. Pete is an ops engineer at a mid-sized SaaS company. Every Thursday night, he manually SSH'd into 18 servers to deploy the latest release. One night, he accidentally skipped server 14. Half the customers saw the old version, half the new. Transactions broke, and support tickets spiked. The whole process took 4 hours and left him dreading weekends. GitHub Actions replaces that nightmare with a single config file. You push code to a branch, and it automatically runs tests, builds artifacts, and deploys to staging. Then, with manual approval, to production. This is what CI/CD means, continuous integration, where every change is tested the moment it lands, and continuous delivery, where every passing change is ready to ship. You write the workflow once. It protects your weekends forever. Here is the exact pipeline that would have saved Pete's Thursday nights. A push to any branch triggers the workflow. That's the onPush event. The runner checks out the code fresh, runs the test suite, and builds the project. If all passes, it deploys to a staging environment where QA can verify. A manual approval step acts as a human gate. Nobody can push to production without an explicit click. Once approved, the same tested artifact ships to production automatically. Every step is version controlled in your GitHub repo. So if you ever need to roll back, you just revert the workflow file. Don't worry about memorizing every line of this workflow file. The important thing is understanding what each section does. Create a folder named .github workflows, then create a file such as ci.yml. The workflow begins with a name, defines when it should run, such as on every push or pull request, and then describes the jobs GitHub should execute. In this example, the runner checks out your code, installs dependencies, and runs your automated tests. If every step succeeds, GitHub marks the workflow with a green check. If any step fails, the workflow stops immediately, giving you clear feedback before the code reaches production. When a workflow fails, don't panic. Head over to the Actions tab in your repository. It lists every run, color-coded green for pass, red for fail. Click the failed run, and you'll see each job broken out. Expand the test job, and you get the exact logs from npm test. The same output you'd see in your terminal. The runner shows you which step failed and why. Once you fix the bug in your code, push the commit, and the workflow fires again automatically. Or if the failure was a transient issue, you can hit Rerun Jobs right from this screen. No SSH required. Your secrets live in repository settings. Click the Settings tab, then Secrets and Variables, then Actions. Hit New Repository Secret. Give it a name like API Key and paste your key. Then in your workflow, YAML, you reference it as $double curly secrets .api key double curly. GitHub masks it in logs so the value never leaks. Quick review. Where should API keys and authentication tokens be stored when using GitHub Actions? Take a moment before answering. The answer is GitHub repository secrets. Secrets are encrypted, hidden from workflow logs, and never committed to source control. Keeping credentials out of your repository is one of the simplest and most important security habits every professional developer should build. The .gitignore file is not optional. It's your first line of defense against leaking secrets and junk into your repo. Inside it, you'll want at minimum .env, node_modules /star.log, and any configuration file that contains real tokens or database passwords. Create this file the moment you type Git in it, and commit it before you push anything. There is no undo for a secret that hits the public internet. Changing it is the only fix, and that costs you hours while the system is down. Stamp this file as approved and make it a habit. So you want to automate your workflow, but where should the guard live? Git hooks run right on your laptop. A pre-commit hook, for example, stops a broken lint job before it even becomes a commit. GitHub Actions, on the other hand, live in the cloud. They spring into motion after you push code, running tests, building artifacts, or deploying to staging. Hooks are your personal quality gate. Actions are the team-wide safety net. Use both. Hooks catch the small stuff early. Actions enforce the big picture rules for everyone. Create a file named pre-commit inside the hidden .git/hooks directory. Start with the shell shebang. Then add a script that detects trailing whitespace. If whitespace is found, the hook aborts the commit. Make it executable with chmod +x. Now your repository won't accept dirty files. Inside your repository, head to the Security tab. Flip the switch on Dependabot alerts, and GitHub instantly scans your dependencies for known vulnerabilities. When it finds one, you'll see a pull request already open with the exact fix, a single click to review and merge. Meanwhile, enable secret scanning. If you ever try to push an API key or token, GitHub stops the push cold and surfaces an alert. Two built-in defenses that cost zero extra and run automatically. You don't have to live in the terminal. Visual Studio has deep Git integration. Clone, branch, commit, and create pull requests without leaving the editor. If you use NeoVim, plugins like util.gh bring GitHub CLI straight into your editor, while util.octo lets you review PRs and manage issues in a split. And the Telescope Git File History plugin is a time machine. Fuzzy search through every version of a file. Jump to any commit instantly. Getting comfortable with these tools cuts your Git round trips in half. Let's finish with one practical question. You've created a Git repository, developed a feature on its own branch, opened a pull request, passed automated tests, and received approval. What's the final step before your teammates receive the new feature? Pause for a moment before answering. The answer is merge the pull request into the main branch. That single action combines all of the work you've completed throughout this lesson and makes the new feature part of your team's shared codebase. Everything you've learned today, from commits to branching to automation, supports that final step. Now let's glue everything together with Claude code. You can give Claude a single sentence and it outputs a branch, the code change, a commit message, and even opens a pull request using the GitHub CLI. This isn't just a code reviewer anymore, it's your automation copilot. If you've been following the series, you already know Claude can generate and review code. Now it can orchestrate the entire Git plus GitHub workflow in one shot. So what did we actually build today? First, you now have Git mastery, branching, merging, conflict resolution, the skills that keep production safe. Second, you know GitHub inside out, remote repos, pull requests, code review, and how to avoid the $2 million mistake. Third, you can automate testing and deployment with GitHub Actions, turning weekends back into weekends. And fourth, you've seen how Claude Code can supercharge every part of your workflow, from PR reviews to end-to-end automation. Walk into your next team meeting with these skills, and you'll be the one people turn to when things get real. That wraps up this lesson in the Claude Masterclass. Now it's your turn. Open a repository, create a feature branch, make a few commits, and practice the workflow yourself. Nothing builds confidence faster than hands-on experience. In the next lesson, we'll learn how to use Claude Code to navigate and debug large, unfamiliar code bases using systematic troubleshooting techniques. If you're following the series, I'll see you in the next lesson. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.